Pre-commissioning and commissioning are two very important and distinct stages of the commissioning process. They are often confused, and it can be tricky to determine what takes place during each of these stages. Let's review the importance of each stage of the commissioning process and what activities take place during each stage. Welcome to the Commissioning and Startup YouTube channel. My name is Paul Turner, and I help people and projects understand the complex commissioning process. Pre-commissioning is an important part of the commissioning process. If not done properly, small issues can become much bigger issues later in the project. Handover from the construction team to the commissioning team precedes pre-commissioning, and it is called mechanical completion. This important milestone signifies the start of the pre-commissioning activities. Since equipment was verified during factory acceptance testing, it was disassembled and shipped to site, and there is always a possibility of damage during shipping or installation. Pre-commissioning testing confirms that no damage to equipment occurred and that on-site test results align with the test results from the factory. There are a few terms related to off-site and on-site testing. FAT, or factory acceptance testing, is the testing that's conducted by the manufacturer in the factory prior to shipping to site. SAT, which is site acceptance testing, is the testing that's conducted in the field, either by the vendor or by the on-site commissioning team. These are the standalone tests to confirm no damage during shipping or installation. SIT, or site integration testing, is the testing conducted in the field to confirm equipment functions as a system. Pre-commissioning activities vary depending on the equipment to be tested, for example, mechanical versus electrical subsystems. Some typical mechanical pre-commissioning testing includes pipe flushing, which is ensuring that piping is free of blockages or any debris, leak testing to ensure that all fittings and joints do not leak, pressure testing, ensuring piping can maintain pressure of liquid or gas, verification of rotational equipment, which is the first rotation of mechanical shafts and bearings to ensure balancing and no excessive vibration, or HVAC testing, which is test and balancing of airflows and ductwork, and heating and cooling sensors and controls. Some examples of electrical pre-commissioning activities are grounding and bonding checks to confirm the integrity of the ground system and bonding system by measuring the resistance of bonds to ensure bonding to all metallic surfaces is in place. Cold loop checks and megger checks confirm that all cable and conductors are terminated to the correct terminal blocks. As well, megger checks apply voltage across the cable conductor and insulation to confirm that the cable has not been damaged or punctured to degrade the dielectric properties of the cable. Hot loop checks confirm calibration settings and ranges of each control loop from the HMI to the end device, including all cables and instruments. This confirms that ranges and set points are correct for each control point. AC phase checks verify installation of each electrical phase in the proper order using a phase rotation meter. Transformer checks. Prior to first energization of the transformer, oil samples are taken, as well as samples taken after energization. These samples are compared to see if there's any differences that could indicate an internal problem within the transformer. Winding resistance measurements are taken as well to measure insulation resistance. Transformer ratios are measured once tap changers are set to confirm that the primary and secondary windings are correct. Open circuit tests are conducted to measure the no-load current losses, as well as short circuit tests performed with reduced voltage to the primary winding to measure full load current losses. During protection relay testing, primary and secondary injections are performed of CTs and PTs to verify relay inputs are correct. During interlock verification, interlocks are verified by operating equipment without bus voltage applied, and the different configurations are verified to confirm that interlocks are functioning correctly before applying any bus power to the system. AC and DC high pot tests. This measures the ability of a dielectric to withstand rated and transient voltage. Battery discharge tests. This confirms how many hours of rated voltage and current can be supplied during charge and discharge cycles. Pre-commissioning is complete once you've completed all your checklists and verified that each piece of equipment meets the technical requirements of the project. Pre-commissioning tests equipment as standalone items. Tests during pre-commissioning don't necessarily operate the equipment as a system yet. Each piece of equipment is individually confirmed to be ready for further commissioning tests. Pre-commissioning is also known as vendor startup, since each vendor's equipment is started for the first time on site to confirm function of each piece of equipment. Following pre-commissioning, we can now move into commissioning tests. Commissioning involves testing multiple pieces of equipment together to function as one system. For example, a chemical dosing skid is made up of pumps, piping, valves, pressure gauges, flow meters, VFDs, and a PLC controller. During commissioning, all of these components are tested together as one system, integrated as a chemical dosing system. The PLC controller is verified to control each piece of equipment as a subsystem to properly dose chemicals to the desired rate. Each subsystem undergoes commissioning tests to verify proper function. Eventually, subsystems are integrated with other subsystems to accomplish the project's intended purpose as one system. For example, the chemical dosing subsystem may feed a water purification system that implements the overall plant process as a water treatment plant. Commissioning involves building up each part of the project to implement the overall plant process. Once each part of the system is complete commissioning, the plant process is then ready for startup, where the new facilities are brought online for the first time for their intended purpose in preparation for ongoing operation and maintenance for the life of the plant. This is the difference between pre-commissioning and commissioning, the difference of testing equipment individually versus testing a group of equipment as a subsystem. Sometimes tests can be classified slightly differently from project to project, but classification as one or the other is not too critical. It is most important that no tests are skipped. Some projects may try to skip pre-commissioning tests and go straight to commissioning. This always leads to problems. For example, if debris remains in mechanical piping, flow rates will not be as expected and guaranteed that more time will be required to disassemble piping, remove the debris, then continue with commissioning tests. Skipping tests in the process rarely results in saved time. A properly planned and executed commissioning sequence will include all pre-commissioning and commissioning tests required to demonstrate a properly functioning system. If you'd like to learn more about the commissioning and startup process, please join my free 3-day mini course. The course is free and flexible to take anytime online. You can join the course at the link in the description below. Also, please subscribe so that you don't miss any of our videos to help you learn the commissioning and startup process. See you on site!